In this video, we're going to go over hypothesis testing. So this is going to be a very simple introduction here to the hypothesis testing. I mean, just think about this at a very simple level as kind of like the scientific process or the scientific method where you are going through a series of steps through a process to ultimately come to a conclusion, right? And so let's go ahead and jump into the hypothesis testing here and get a better understanding of how exactly this works. So hypothesis means an idea made from limited evidence, right? We're making a guesstimate. We're making some sort of claim based on certain limited information, right? It's the starting point for further investigation, and there's a 7-step process. So the first step here is to make an assumption, right? Assumptions are related to the distribution of data, sampling, right? And so we're just making an assumption here of what we think we're going to see or what we think is going to happen, right? And so then we take the initial position. This is the HO. So the null hypothesis is the initial position. It is a status quo position. It is the position that is rejected or failed. And so this is the position that needs to be validated and actually tested to make sure that it's true, right? And then determine the alternate position. Step number 3. The alternate hypothesis is the contrary position to null hypothesis. If there's statistically significant evidence that suggests that the alternate hypothesis is valid, then the null hypothesis is rejected. And we're going to get into the null and what that means in the HO and HA here in a moment. And so the next step is to set acceptance criteria. So the null and the alternate hypothesis is defined. The status quo is the null hypothesis, and then at this time, a threshold needs to be set. So number 5 here, we conduct fact-based tests, right? So this is where the testing is done. The predications are made and the outcomes are noted. So again, think about this very simply and easily as the scientific method, right? We're forming a particular hypothesis, we're testing it, we're analyzing the information, we're interpreting, right? And then we're able to understand whether or not it works or doesn't work, right? And then number 6 here, we're evaluating results. So does the evaluation support the initial position? Are we confident that the result is not due to chance, right? Very important there to understand. And then finally here, number 7 is to reach one of the following conclusions, right? So we either reject the original position in favor of an alternate position, or we fail to reject the initial position, that was there initially, right? So that's ultimately what hypothesis testing is really about. Let's go ahead and get into some terminology here now. So the null hypothesis, the HO, the null hypothesis is the hypothesis that is to be tested for possible rejection under the assumption that it is true. The concept of the null is similar to innocent until proven guilty. And then the alternate hypothesis, right, which is the H1 or HA, the null hypothesis and the alternate hypothesis are mutually exclusive statements. So if the null hypothesis is commonly accepted facts, then the alternate hypothesis is a real fact based on observation from the sample data. It's denoted by H1 or HA. And a good example here is, let's say a soap company claims that its product kills on average of 99% of germs, okay? So to test the claim of this company, we will formulate the null and alternate hypothesis. So the null hypothesis, right, the HO, is the average equals 99%. And then the alternate hypothesis, the H1 here, is the average is not equal to 99%. So this is very, very easy and simple to understand, right? It's just sometimes I, don't really understand why a lot of times this information can get quite complex. I think it's how it's presented by individuals, and I think the, computer science folks want to make this as technical and complex as they can. I don't know, I'm just taking a guesstimation here because myself, I'm more of a big picture thinker, high level type of, thinker, where I want to know, what is the facts, right? What is the outcome? What is it, the big picture here as far as what we're ultimately looking to accomplish. And this example here really gives that, pretty much understanding of this is super simple. It's the null hypothesis. It's either yes or the alternate, which is either no. I mean, it's literally that simple. But like I said, sometimes I think it can lead to being a lot more complicated than it really is because there's so much information and so many different algorithms and formulas, right? But ultimately, like I said, it's really about the null hypothesis. Either it is or it isn't, right? And so simple and composite hypothesis testing. So in this particular situation, when a hypothesis specifies an exact value of the parameter, it is a simple hypothesis, and if it specifies a range of values, then it's called a composite hypothesis, right? Look at the difference there and understand that. And so an example here is a motorcycle company claiming that a certain model gives an average mileage of 100 miles per gallon, right? So the vehicle, the particular, bike or whatever it is there, right? Or the particular motorcycle, right? It's giving you 100 miles per gallon. That's the case here for the simple hypothesis. And so another example here is the average age of the students in a class that is greater than 20. So this statement is a composite hypothesis, right? So that's going to be the differences there as far as, the simple and composite hypothesis testing. We're looking at two different variables there, and really these two examples here should give you the basic understanding. So now let's look at the one-tailed and two-tailed hypothesis testing. So if the alternate hypothesis gives the alternate in both directions, right, of the value of the parameter specified in the null hypothesis, it is called a two-tailed test. And so if the alternate hypothesis gives the alternate in only one direction, right, either less than or greater than of the value of the parameter specified in the null hypothesis, then it is called a one-tailed test. And so here we can see that according to H1, the mean can be greater or less than 100, right? This is an example of a two-tailed test. Similar here to if the mean is less than 100, it is called a one-tailed test, right? Okay, so let's take a look at the critical region here. So the critical region is also known as the rejection region, right? It's the set of values for which the null hypothesis is rejected. So you can see here on the left-hand side of this particular bell curve here, you have the critical region, and on the right-hand side, you have the other critical region. So a good example here would be, let's say you're looking to rent an apartment, okay? And you list out all of the available apartments from, all the various websites. So you have a budget of, let's say, $15,000 a month. So you can't spend more than that, right? And the list of apartments you made has a price ranging from $7,000 to $30,000 a month. And so you select a random apartment from the list and assume the below hypothesis. So the HO, you will rent the apartment. H1, you won't rent the apartment, right? And then you reject all apartments above 15,000. So very, very simple here, very easy for us to understand this. And so all the prices greater than 15,000 become your critical region. That's very, very simple for you to understand. Hopefully you're able to grasp that, right? Because the critical region is on the outskirts, right? In the middle of the bell curve, those are all the apartments that are within your budget range, right? And so the ones that are in the critical regions are going to be outside, right? And so the critical region lies in the one tail or two tail on the probability distribution curve, right? According to the alternate hypothesis. And so in this video, I just wanted to give you an overview of the hypothesis testing, how we're going to be using this, how to understand, hypothesis testing as far as one-tailed, two-tailed, the critical regions, understanding the bell curve, right? And we're going to get into this in deeper lessons, but just wanted to give you an overview here of how you're able to, go into a particular hypothesis and be able to go through the various steps to come to an ultimate conclusion, right? So that's going to be here for this one, and we'll see you on the next one.